Okay, so you go ahead and label your notes for today, scatter plots and lines of fit. I'm more interested in the second half of this statement. Have you ever heard that phrase before? A line of fit. Maybe you heard it called a trend line, a prediction line. Heard any of those statements before? Okay. How many of you know what a scatter plot is? Give it to me in your words. What's a scatter plot, Dylan?
It's just a plot thing that's like doesn't make a line, really.
Okay, good. It doesn't make a line. It makes a bunch of points. Almost kind of looks like a shotgun kind of spray sometimes. It could have a pattern.
A graph with lines with dots all over.
Okay, a graph with dots all over it. Yeah. What's the point of a scatter plot? You're like, that's a great question. Yeah, I mean that's not yes, but I mean, is that what I want to use it for? Okay. All right. So when I get into a scatter plot, I really am looking for one of three things. I want to see if these values are related to each other, and they can be related in one of two ways, or maybe they're not related at all. All right. I use this all the time in a very generic sense, right? As a basketball coach, I look at a kid coming in, like I just got a sophomore transfer that came in that's going to play for us this year. I look at him, he's 6'2" right now, and he's got these big floppy feet. What's my thought as a basketball coach? I see he's already 6'2" and he's got big floppy feet. He's what? He's going to trip. That was not my first thought.
He's gonna wear high shoes.
Nah. I look at him as having big feet and saying, man, I bet this kid is going to do what? He's going to grow. Because typically, the bigger you are, what's true about your foot size? Typically, it's bigger, right? So if he's 6'2" right now and I'm looking at his feet going, man, those things are huge, I'm saying yes, right? Because I'm banking on the fact that he is about to keep on growing. Okay? Now, if I look at a kid and he's already 6'2" and I look at his feet and I'm like, man, what do you wear? Like a size 9, 10? What's my thought there? Yeah, he's done. He's already maxed out. Like he's probably bigger than what he was supposed to be in the first place. Okay, yeah, like this guy might actually get smaller on me. Okay, so we use this information all the time to kind of further our thought process, either in a good way or in a bad way. Doesn't always have to be a positive. Okay, so that's what we're going to get into today. We're going to use the idea of a scatter plot to then make a prediction about what we think is going to take place. And that's what that line of fit is all about. So we're going to use our skills of being able to write an equation to help us do that. All right, we already did that. So that's kind of what our goals are, right? We're going to look for relationships. Sometimes there's not a relationship to be had, like your shoe size and how smart you are, right? People with big feet aren't smarter than people with small feet. I mean, maybe they are, but well, okay, I got a huge head. Well, I am pretty smart, so thanks. How big's your head? 7 3/8 all the way around this thing. It's like the size of the earth. Okay, if you ever wear a fitted hat. What's that? Oh, yeah. All right. So there are three types of correlation. If you just visually think about it, what should a positive correlation look like? What should it look like? Going uphill. Yeah, I'd agree with you. Right. A negative correlation should be going down, we would assume, right? And then no correlation would be doesn't necessarily have to be flat. Yeah, they're just kind of haphazardly, kind of all over the place. Like they're just kind of out there, right? Because the two things that we're trying to compare don't belong together. All right. When they do belong together, then we see them start to kind of form one of these two directions. All right. Now, positive relationships mean that as one value that I'm comparing grows, so does the other. So we would tend to think, and some of you are going to disagree with this statement, but we would tend to think the more time we spend studying, the better we do. Right? Some of you would say, no, I don't study at all and I still do well. Right? And some of you would say, well, I study a bunch and it still doesn't help. Okay. But typically, the more time we put into something, and it doesn't have to be academics, right? It could be video games. Sure, the more you practice, or you're going to be better. I mean, that would be generally a true statement in any aspect. Now, this can also work against us in a negative relationship. How many of you, when you go home from school, like take a nap? If you go home and take a nap, two hands, all right. If you go home and take a nap, you now have less time for everything else, whatever that is, whether it's homework, whether it's eating, whether it's socializing, whatever it is, you have less time because you're spending some of your time sleeping. All right. How many of you are involved in some type of extracurricular? Okay. If that's the case, you also, as you spend more time doing one, you have less for another, right? Like we want to come in and say, I didn't do my homework last night because I had a game and then we didn't get back until 10 o'clock and then until I got home and it was 11:30 and I just went to bed, right? All of your time was spent doing one thing and left you no time for something else, right? I mean, and those things happen too. And then sometimes we try to put two things together and they just don't belong together, like the last option. Sleeping and video games at the same time. That's a tough one. All right. If you look at this one here, just by looking at the picture, you'll quickly be able to tell me what the correlation is, I would assume. Maddie, you would say the correlation there is what? Negative. Now, what does negative mean in this situation, though? Look at the title. What does negative mean in this situation? Maria, Mia, what do you think?
As years increase, the students per computer decrease.
Okay. Is that a good thing or a bad thing?
I think it's a good thing.
It is a good thing, right?
That means there's probably more computers or not as many people.
Okay, good, right? There's really two scenarios there. Either we're getting more computers or there's just less people coming around, right? Either way, less people are having to share a computer, which ultimately is a good thing, right? So just because it's negative doesn't mean that the result has to be a bad thing. In this situation, it actually is a good thing. Maybe.
If there's less kids coming to school, then that's not a good thing.
Well, that's true. If there's less kids coming around, then that's not necessarily a good thing. Okay, what if I take the picture away, but I keep the scenario? Is this good? Is this a positive thing, a positive relationship? Is it a negative relationship? Or is there absolutely no relationship between the two? The average temperature in the city and the number of speeding tickets given. Trent, what do you think?
Well, maybe there's that because maybe the higher the temperature, the
Yeah.
more people will be outside.
Okay, totally agree with you on that statement.
And then there's sports clubs.
Yeah, okay, good. We're about to hit into, I mean, who woke up this morning and was like, seriously, it snowed last night, right? If
It was
it,
snowing at like 7:10.
Yeah. Well, I was at the Browns game yesterday and it snowed like 5 or 6 times during the game. I was like, this is not fun. All right. If you think about it, how many of you know somebody who owns a sports car, a muscle car, a convertible, motorcycle, something that goes fast, right? How many of those types of vehicles are you going to see on the road for the next 3 or 4 months?
Not that much.
Right. We're not bringing them out, right? Those things are going to go away in the garage. They're going to stay there until it gets nice out again, right? Okay. So just like you said, Trent, like when that temperature drops, I think we start to see those types of vehicles also drop. They're just not around. Now that doesn't mean somebody's not going to go fast in the snow, right? That still happens, okay? But typically, as the temperature increases, that's when we see the types of cars or vehicles that are going to do those types of things.
Not only that, but the snow can prevent people from high speed.
Sure. So what type of relationship would that be? When we have higher temperatures, we see more of those types of cars. And when we see lower temperatures, we see less of those types of cars.
I think that's like
There definitely is a relationship, right?
yeah,
So it's either positive or negative.
positive.
It is positive, right? High gets paired with high, low gets paired with low. That moves in a positive relationship. What's up?
So technically, just by looking at the sentence, you can't technically see like that, same things qualities together.
Right.
Because you don't see like the amount because they could just be like speeding tickets for a certain type of car.
Sure. Sure.
So you don't know.
Sure. I mean, we're just trying to make like a general statement there. Yeah, but you're right. I mean, that's not obviously always going to be the case. What about this one? The number of people in the audience and the ticket sales. First of all, is there a relationship? If you say yes, then it either has to be a positive relationship or a negative, or you're saying no, these don't belong together at all. What do you think? Should be, right? I mean, if we sell the tickets, there should be butts in the seats, right? I mean, ultimately, unless you just decided to buy a ticket and not go, which I guess is an option, but chances are probably not. There you go. I bought the ticket, so you can't sit there. All right. A runner's time and the distance to the finish line. Do those two things relate to each other? You're running a race. Your overall time and the distance you have to the finish line. Me, what do you think?
I think it depends on what kind of race you're doing.
Uh,
Like the fast ones, like you have to go really fast.
yeah,
Like you have to go as fast as you can.
yeah. Is there a race where you'd go slow?
This is like
A crawling race.
the turtle ball.
You think about this for a second. Your time. What happens as you're running a race? What does your time do? Your time increases no matter what. It doesn't matter whether you're running a 100-yard dash or you're running the mile. When you start, your time takes off. What is your relationship, though, to the finish line? As you're moving, what's your relationship to the finish line?
The faster you move in the finish line,
Uh,
slower it takes you to run.
I mean, what is it? The distance to the finish line. It would decrease, no matter what it is, right? Let the doorway be the finish line. When you say go and I take off, my time is increasing right now, but my distance to this door is getting smaller. So one value is growing, one value is decreasing. What type of relationship is that? That is a negative relationship, right? One value is increasing while the other is decreasing. What about this one? The temperature in Houston and the number of cars sold in Boston.
No.
So there we have one that those two don't rely on each other. Yeah, like the guy down in Boston's like, hey, bud, what's the temperature down there in Houston today? 85. Okay, that means good day selling cars, right? Like that doesn't, it's not real. What about this one? A Canadian. I don't have a good Boston accent. That's what you need. The number of times you sharpen your pencil and the length of your pencil. Do those two things have a relationship, first of all?
Yes.
Okay, what is it? Evan, what do you think? Getting smaller. So that relationship would be the more times I do one, the smaller the other one's getting. Negative. It would be awesome if it was positive, though. Right? Could you imagine that? You sharpen your pencil and it just grows. Right? That would be sweet. How about this one? Last one. The number of members of family in your, or number of members in your family and the size of your grocery bill. Sam? Yeah. Those of you with many siblings, right? Whoever's in charge of trying to figure out how to pay that bill just cringes when you go to the store, right? Because you just know, right? Or like I go to the grocery store and I swear 2 days later they've eaten it all. I'm like, how is that even possible? Like I just dropped $300 and you guys ate everything in sight.
They're gluttons. And he'll go every 3 weeks and he just buys like a buttload of stuff.
Yeah, it's
And he's like gone.
so now. I mean, obviously, we all could say this varies a little bit, but nonetheless, the more people in the house, the more food that's going to be consumed, right? I mean, that just is what it is. So, true, yes, and the bigger they get, right? Absolutely. All right. So, the paper you have in front of you, okay? Here's what we're going to do. First, we're going to make a scatter plot. That shouldn't be the big deal. Secondly, we're going to determine whether there's a relationship. So, thinking kind of along the lines that we just did. Then we're going to get into this idea of, can I draw a line that models this data? Because ultimately what I would like to do is make a prediction about what's coming down the line. Okay. Today we're going to do this by hand. Tomorrow we're going to get into using a program to help us. So whether it be Desmos or whether it be a graphing calculator, we can do this a couple different ways. Then we're going to pick some points that are a part of that line so we can write an equation. So that's going to come into your, am I a y minus y1 user, or am I a y equals mx plus b user? And then we'll use it to make a prediction. All right. So you have a copy of what this looks like on your desk. The local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are the figures for the last 12 days. Just looking at this relationship, we're talking about the temperature versus how much ice cream they sell. Would you expect this result to be positive, negative, or have no relationship?
Positive.
Positive. My wife would say there's no relationship. 100%. She would. She would tell you there's absolutely no relationship. Yeah, because she would eat ice cream no matter what. Okay? Whether it's freezing outside, whether it's hot outside, whether it's at night, whether it's in the morning, I don't think she cares, to be honest with you. She would eat ice cream no matter what. And she would tell you that. Like, I'm not calling her out. Like, you went down there, she'd be like, yeah, you got some? That's what she would say. Okay? So we would expect the result to be positive, right? Is that what you were going to say? I'm sorry. But if I think about plotting this, we would think that these should start to move uphill, right? Now, some of us are already starting this, and that's great. Before you do this, though, what kind of things need to be on your graph before you can start plotting? What's got to be there? One, like what? Okay. Okay, so where do those things belong? Like, which one belongs on the x-axis? Which one belongs on the y-axis? Sam? I didn't give you one, or you didn't pick one up at the beginning of class like everybody else? Even though it was written on the board. Okay, what are you thinking?
The x-axis would be temperature.
Okay.
Y-axis is
Good. So think like an ordered pair. That should be x, and the sales should be y. So in my graph over here, all right, this is going to be temperature down here, and this is going to be sales on that axis, right? So now I need a scale. If you didn't create a scale, my biggest temperature is 25.1. So I probably don't have enough to count across the x-axis by ones. Do I have enough to count by twos? So then let's do that. Okay. So even though I'm only marking out every 4, I'm still obviously counting by twos. Okay. So there's enough to count that way. And across the vertical, I think I see a highest value there of like 614. So what do you want to count by vertically? I think if we count by hundreds, that would have my entire graph. Like my entire graph would only be up like this many units. So maybe let's count by 50s. That'll at least stretch it out a little bit. So that'd be 100 there, 2, 3, 4, 5, 6, and then I'll go to 7 just because I need to be above that highest mark. Okay. So I don't know. Take the next 60 seconds is probably enough to go ahead and plot those points. I'm going to bring a ruler to you because ultimately what I need to be able to do after I plot these values is I need to create a line. A line that does a couple things. One that follows the ordered pairs on my graph. One that models a relationship that I can follow, and ultimately I can make a prediction with.
No rollers on?
What's that?
No rollers on?
I know rulers on.
Oh, you messed up. You did no rollers.
Oh. Okay. So, do you already have those plotted? Well, what are you waiting on? Okay. It'll be all right. So kind of just keep track as you're going through these so that you make sure you have them all and you haven't missed anything along the way. And obviously, I mean, we're not going to be 100% accurate, but we can get pretty darn close. Remember, every one of our units there is 50, so floating something in the middle of a box should represent roughly 25. So as you start to see the path of these dots that are being laid out on your graph, they are falling into that positive relationship that we thought, which means we can use this to help us make predictions. Once you've finished, what I would like you to do is to try to use that ruler and lightly, I'd like you to try to lay a line on there that best represents the direction of your dots. So think about this as you're doing it. Try to hit as many of them as you can. And if you can't hit any of them, or obviously you can't hit them all, then try to make sure that there's an equal number above and below. Okay? You obviously cannot draw a straight line through all of these dots, right? But the ones that you don't hit, we would like to try to have as many above as we have below. I would say to you that your line probably goes more that way than it does that way. So do this and it's hard sometimes with a ruler unless you have one that's clear, because you're kind of unable to you're taking away half your information as soon as you lay that ruler down, right? I mean, you're blocking a good majority of your information, so it is difficult. But when you do it, try to lay something out there that looks like it's hitting as many of those dots as you can. And like I said, if you're not hitting them, are we equally dispersing what's left over? Like, should it be maybe a little bit more like that? Okay, so if that was the case, right? Now, when you do this, though, you got to have at least 2 that are on your graph. No. Like, so if I look at mine, I'd say, I hit 1 here, 1, 2, 3, 4, 5, give or take. And it looks like I got about 3 or 4 below and 3 above. So that's pretty close. Now, obviously, depending on how accurate you were with placing your dots, that matters. Okay. Once you've done this, the whole point of that line is for you to be able to make a prediction. You can't make a prediction unless we can turn that line into an actual equation. So our goal right now is to turn this line into some y equals mx plus b statement. That's how I'll make a prediction. if you want to be able to write the equation of that line, you have to know two things. What are the two things you got to know? You got to know the slope and the y-intercept. You're going to need two ordered pairs, though, to do that. So come back over to your picture and identify 2 points that are 100% a part of your line, like you're certain. So I'm going to say like that bottom one for me. So that's this ordered pair right here. That's definitely on my line. And I don't know. I'm going to take that one right there. So that's going to be this 22.1 and 522. Those two ordered pairs I would say are on my line. All right, so find two that are on your line. And tomorrow when we come to class, we're going to use a computer and it's going to tell us what is the best line. So we're going to see how accurate you were to what the computer says. So don't lose this sheet of paper that we're using right now. But I've got two ordered pairs, 11.9, comma 185, and I've got the order pair 22.1, comma 522. So what's the slope and what's the y-intercept? And your line's going to be different than mine, and that's okay. We'll see who's better. Okay, what's up? You should be doing yours. So these are the two that were on mine. So that's what I'm going to do. But you're going to do yours, and we're going to see tomorrow who's better. You think you're better? We're going to find out. So do you have your slope yet? Yeah. So that's where you got to start, right? Y2 minus y1 over x2 minus x1. Figure out what your slope is. Now here, you don't need to leave this answer as a fraction because we're going to use it in an equation. So a decimal will be fine. If we were graphing it, a decimal would not be fine. But here it will be. And I'm going to take mine, and we'll see what it looks like before. So I'm going to take mine to the nearest hundredth. So that'll leave me with a slope of 33.04. What's that? 30? Okay. So if my slope's at 33 and your slope's at 30, then our lines are going to have a little bit different of a pitch, right? Mine's going to be a little bit steeper than yours. Okay. So like I said, we'll see tomorrow what is the best slope for this line? What is the best y-intercept for this line? We'll find that out. Okay. Now remember, once you have a slope, take that slope in one of your ordered pairs and then figure out what your y-intercept is. What's up? Okay. Okay.
How did you get 30?
I did 337 divided by 10.2. Look at your calculator. You have 340, not 337. No. Okay. Did you? So it just depends on what 2 points, obviously, you're using in yours. Because remember, to write an equation of a line, you got to have 2 points. So, and then either use the y minus y1 or use y equals mx plus b. I'm going to use y minus y1. I have no idea what 33.04 times 11.9 is. That'll be a negative 393.176. And then I'll move over the 185. It looks like my y-intercept here is going to be a negative. Is that okay? How do you figure? Well, if you look at the equation on the board, if you extended that black line, would it cross above or below the y-axis or above the x-axis? Which one? Above or below the x-axis? I mean, if I extended this line, right? I mean, if I extend that line, it's going to be below the x-axis. So will I have a negative y-intercept? And the answer would be yes. Now, the whole point of this line is to make a prediction, to say what's going to happen in the future. So if you take your equation, or if I take my equation, doesn't matter, right? And I put in a temperature. Now, mind you, all these temperatures here obviously are in Celsius, right? But if I said, it's going to be 22 degrees Celsius out today, all right, that's what the forecast for the weather says. If I take my slope of 33.04 and I multiply it by 22, and then I put in my y-intercept, which is minus 208.176, and I hit enter, it says that I should make about $518.70. As an owner, that's useful information, right? Because the warmer the temperature is, the more money I could expect to make. I may need more people to work, right? If the temperature is going to be lower and I'm going to make less money, then I might not need more people to work, okay? So I kind of can use this to help me make predictions about what's going to happen down the line. Yes, sir? Sure. If it rains. Yeah. Especially if you got like a walk-up business, right? Like Cherry Street, right? Where there's no place to go inside. So if the weather is bad, that may drive people away. Right? I mean, like they don't want to stand outside to get their ice cream. What's that? That's true, right? Yeah, well, COVID, right? Nobody can go in anyways. So obviously. All right. Last thing before we leave. When we make predictions, take a look at these two things. I want you to put them on your graph. All right. When we make predictions inside of our data, okay, meaning that I have information to support the answer I'm about to give, that's called interpolation. When we make predictions in here, like when you talk about stuff in there, because you have ice cream sales from 12 degrees all the way up to about 25 degrees. So when you make a prediction inside of there, that's called interpolation. When you try to extend it outside that range, that's called extrapolation or extrapolation. Okay. You're now trying to say, well, what if it got all the way up to this point? Like, how much money could I expect to make? Which one of these is a more accurate representation? Yes, 100%, right? Because you have information to support this. Do you have information to support this? No, you're using the fact that this is a linear line and it just keeps going to say, hey, listen, here's what could happen, right? I mean, water boils at 100 degrees Celsius. If I put 100 into this equation, it's going to tell me how much money I could expect to make. If it was 100 degrees Celsius outside, that means it's 212 degrees in Fahrenheit. Don't worry, you're not buying ice cream, you're dead, okay? But according to this line, it would tell me that I could do it. So it loses its value at a certain point, okay? Oh, you're not buying anything. You're melted. You're gone, okay? You're a way past goner. You're a little fried crisp somewhere, right? You're gone, okay? So extrapolation, loses its value at some point, okay? Two things. Number one, don't lose this paper because we're going to use it tomorrow in class. Number two, your homework for tonight is a Google form. That Google form has 12 questions, but I'm going to grade it on this 10-point scale. So if you get 9 or 10 of them correct, that'll be worth the full credit. If you get 7 or 8 of them correct, you'll get the 4-point credit, so on and so forth. Okay, so it's got 12 questions, but it's getting graded out of 10. Does that make sense?